Okay, welcome to Nobility Learning Center. Today, I will present to you about multiple choice questions, about stoichiometry. This part 2. Okay, last time I presented to you uh, some questions about stoichiometry. Part 1, you can refer it from this YouTube channel. Okay, this is the first question. This is the first question. This is the first question. Chromium is extracted by reacting chromium 3 oxide with carbon. This is the chemical reaction. Cr2O3 plus 3 carbon give us 2 Cr plus 3 CO2. What is the maximum mass of chromium that can be extracted from 38 grams of chromium 3 oxide? The relative atomic mass of chromium and oxygen are given here. A 24 gram, B 26 gram, C 51 gram, D 76 gram. What does maximum mass mean? Maximum mass is the theoretical mass of chromium, okay? The theoretical mass. Theoretical mass is the calculated amount of the product, okay? We can calculate this mass, okay? The mass of chromium, the maximum mass of chromium, that means the theoretical yield, okay? The calculated amount of what? Chromium. How can we find this mass? Okay. Solution. First, write the balanced chemical reaction for our example. Cr2O3 plus 3C give us 2Cr plus 3 CO2. We have 38 grams of what? Cr2O3, and the mass of chromium is what required, and the atomic mass of chromium and oxygen is given. And from this balanced chemical equation, 152 grams of Cr2O3 is reacted with, 152 grams of Cr2O3 required to produce 104 grams. 38 grams of Cr2O3 is required to produce X amount of what? Cr metal. Then we use the mass ratio, 38 gram divided by what? 52 gram, which equals to X over 100 gram. X equals to 26 gram of chromium will be produced from 38 gram of what? Cr2O3. Or you can use 152 gram will produce 104 gram. 38 gram will produce X, and then what? Crisscross. Therefore, the answer must be what? B. It is what? 26 gram. Okay, let's go to the second question. Dodecane C12H26 is a hydrocarbon obtained from petroleum. Ethene C2H4 can be produced from dodecane by the reaction shown in the equation. C12H26 is cracked to produce 2C2H4 plus C8H18, okay? In this reaction, 1 mole of dodecane gave only 22.4 grams of ethene. Calculate the percentage of what? Ethene. Relative atomic mass of hydrogen and carbon are given here. So how can we find the percentage yield? First, what does percentage yield mean? Percentage yield is the ratio, percentage yield is the ratio of what? Theoretical yield to what? Actual yield multiplied by what? 100%. So first, we have to find the theoretical yield. We have the actual yield of what? The product. Ethene is product. C2H4 is ethene. Okay. The mass of the product, actual mass of product is given. Okay. What is the amount of C2H4 theoretically obtained from 1 mole of dodecane? Okay. This is the calculated amount of what? The yield. Okay. Usually the actual yield is given. Usually the actual is given, or it is what required. Actual yield is the measured amount of what the product, but theoretical yield is the expected amount of the calculated amount of what the product. Percentage yield equals to actual yield divided by theoretical yield multiplied by what 100%. This is required. We have to calculate the theoretical yield, which is calculated from 1 mole of C12H26. Okay, 1 mole of C12H26 will produce X amount of C2H4. Okay, theoretical yield is expressed in gram because the actual yield is given in gram. Okay, 22.4 gram is given. Okay, therefore, it's a mole mass problem. Okay, a mole mass problem. You can solve such kind of questions by using what? A mole mass relationship, a mole mass conversion. Okay, 1 mole of C12H26 is reacted with X amount of C2H4. If 1 mole of what 52 gram, if 1 mole of C12H26 is used to produce 52 gram of C2H4, okay, then we use mole ratio here and mass ratio in this one. Okay, 1 mole over 1 mole X, or theoretically divided by what 52 mole. Let's say 1 mole over 1 mole equals to X over 52 gram. X equals to 52 gram of C2H4. This is the theoretical, not the percent yield. We have to calculate the percentage yield now because we already calculated the theoretical yield. The actual yield is given. Therefore, percentage yield equals to actual yield divided by theoretical yield multiplied by what 100%. This equals to 22.4 gram divided by 52 gram multiplied by what 100%. This gives 43.1%. Okay, this is not a multiple choice question, but it is what workout. We have only what the answer equals to 43.1. Okay, the next question. Ammonia is manufactured by the reaction of hydrogen and nitrogen in the Haber process. Okay, let's go to the next question. Ammonia is manufactured by the reaction of hydrogen and nitrogen in the Haber process, as shown in the equation below. Nitrogen plus H2 give us to NH3. 16.8 tons of ammonia can be produced from 14 tons of nitrogen. Okay, here we have what? The amount of the product, 16.8 tons of ammonia produced from 14 tons of what? Nitrogen. How much nitrogen is needed to produce 51 tons of ammonia? Okay, then we can directly calculate the amount of ammonia by using what? This proportion. Okay, 60.8 tons of ammonia used to produce 14 tons of what? Nitrogen. How much nitrogen is needed to produce 51 tons of what? Ammonia? And then you can use the crisscross method. Okay, let's go to the solution. Okay, solution. This is a solution. Okay, this is a solution. Nitrogen plus H2 give us 2NH3. From 16.8 tons, we can obtain 14 tons. From 51 tons, we obtain X amount. Then X equals to 14 times 51 divided by 60.8, which equals to 42.5 tons of hydrogen. Therefore, the answer must be what? A. Okay, question number okay. 6 grams of hydrogen react with 48 grams of oxygen to form water. A chemist performs the same reaction using 2 grams of what? Hydrogen. What mass of oxygen is required to combine with the hydrogen? A, 24 gram, B, 12 gram, C, 16 gram, D72 gram. Okay, solution. This is the chemical reaction. First, write the balanced chemical equation just like this. 2H2 plus O2 produce 2H2O, and write the given mass of hydrogen and oxygen at the top of the formula of hydrogen and oxygen respectively, which is 6 gram and 48 gram respectively, okay? And produces what X amount of what water. And from the stoichiometry proportion, 4 gram of hydrogen must be reacted with 32 gram to produce 36 gram of H2O, okay? The atomic mass of hydrogen is 1, the atomic mass of oxygen is 16, the atomic mass of, yeah, enough, okay? We have only part the atomic mass of hydrogen and oxygen because there is no any other atoms, okay? Hydrogen 1, oxygen 16. Then apply the following two steps. We use the hiding approach, okay? The hiding approach. In the hiding approach, first hide the given 48 gram of what oxygen, okay? This one is hidden. And then find the amount of water, which is X in gram from the given mass of what hydrogen only, okay? 6 gram over 4 gram equals to X over 36 gram. This is equal to X equals to what? 6 times 36 divided by 4, which is 54 gram. And the second step, hide the 6 gram. Okay, the given 6 gram is hidden. Okay, the given mass of what hydrogen is hidden, and then calculate the mass of what water by using the given mass of what oxygen. Okay, which is 48 gram. 48 gram divided by what? 32 gram, which equals to X over 36. This X equals to 48 times 36 divided by 32 gram, which is 54 gram, okay? The two calculated amount of the product is what the same. This implies the given mass 6 gram of the 6 gram of hydrogen and the 48 gram of oxygen are in stoichiometric proportion. Because when we find the amount of water by using this 6 gram of hydrogen and 48 gram of oxygen is what the same, which is 54 gram. This implies what? Both are in stoichiometric proportion. Okay, hydrogen and oxygen are in stoichiometric proportion. Then directly we can calculate the mass of, the mass of, so the reactants are in stoichiometric proportion. From 4 gram hydrogen reacted with 32 gram and 2 gram hydrogen reacted with what? X gram. Then crisscross, the amount of oxygen is X, which equals to 2 times 32 divided by 4, which is 16 gram. Therefore, the answer must be what? C. Okay, the next question. What is the amount of water produced when 8 gram of hydrogen is reacted with 32 gram of what? Oxygen. We have two given amount of reactants, hydrogen and oxygen, which are 8 and 32 gram respectively. Then we are asked to find the amount of what? The product of the yield. Okay, solution. Hydrogen, first write the balanced chemical equation. Hydrogen reacted with oxygen to produce water. 8 gram of hydrogen is given. 32 gram of oxygen also is given. Then first identify the limiting and excess reactant. The limiting reactant determines the amount of the product, which is what? X. Apply the mole ratio method. We can use two methods. The first one is mole ratio method, and the second one is the product approach. But for this example, for this question, we use only the mole ratio method, okay? you can use the product approach method. You will obtain what the same result. The mole of hydrogen equals to 8 gram over 2 gram per mole, which is 4 mole. Mole of oxygen equals 32 over 32, which is 1 mole. By the way, mole is equals to given mass divided by what? Molar mass. Molar mass is the mass of 1 mole of the substance, as we discussed previously. Okay. Mole ratio of, then the second step is calculating the mole ratio of both reactants, hydrogen and oxygen. Okay, mole ratio of hydrogen is 4 mole divided by 2 mole, which is 2. The mole ratio of oxygen is 1 mole divided by 1 mole, which is 1. The mole ratio of O2 is smaller than that of what? Hydrogen. Okay, the mole ratio of hydrogen is 1, 2. The mole ratio of oxygen is 1. Therefore, the mole ratio of oxygen is smaller than that of what? Hydrogen. Therefore, O2 is the limiting reactant because it has what? The smallest mass ratio. Molar ratio. Oxygen has what? The smallest molar ratio. Therefore, oxygen is the limiting reactant. Then we use the given mass of oxygen to calculate the mass of what? The product. Okay, the given mass of oxygen is 32 gram divided by 32 equals to x over 2 mole. Gram cancelled by gram, 32 cancelled by 32, and then x equals to 2 mole of water will be produced from 32 gram of what? Oxygen. The answer is A. Okay, the second question is find the amount of carbon dioxide produced by the composition of 20 gram of what? Methane. Okay, hydrocarbons are composted, burned with oxygen to produce carbon dioxide and water. Then first, write the balanced chemical equation. Methane plus oxygen produce carbon dioxide and water. Okay, then balance this chemical equation. 1 mole of CH4 reacted with 2 mole of oxygen to produce 1 mole of carbon dioxide and 2 mole of water. We have 20 gram of methane used to produce X amount of carbon dioxide if 16 gram of CH4 used to produce 144 gram. And then use the mass ratio method, okay, because this is the mass problem, okay. 20 gram divided by 16 gram, which equals to X over 44 gram. X equals to 20 times 44 divided by 16. 16 by 4 is 4. 20 by 4 is 5. Okay, 4 by 44 is 11. 11 times 5 is 55 gram of carbon dioxide will be produced. There is no answer in the given alternatives. Okay, the alternative A 44 gram, B 20 gram, C 66 gram, D 22 gram. But the answer is 55 gram. There is no answer in the given alternatives. Okay, a 0.10 mole of sample of metal M, atomic mass 70, was burned in oxygen. The oxide produced had a mass of 9.4 gram. How many moles of oxygen combined with 0.1 mole of what? The metal. A 0.1 mole, B 0.15 mole, C 1.5 mole, D 0.075 mole. Okay, to solve this kind of question, we must apply the law of conservation of mass. Okay, let a metal M is combined with oxygen to produce what? A metal oxide. A metal M plus O2 give us what? Metal oxide. The mass of metal oxide obtained is 9.4 gram, but the number of moles of the metal is 0.1 mole. You can calculate the mass. You can convert this 0.1 mole into mass. Okay, according to the law of conservation of mass, the mass of the reactants, the total mass of the reactants equals to total mass of the product. Okay, this 9.4 gram metal oxide equals to the mass of the metal M and the given mass of what? O2. The molar mass of them. First convert this 0.1 mole into what? Mass. How can we convert? apply this formula. Okay, N represents the number of mole, small m is the given mass, big M is the molar mass or the atomic mass of what the metal, which is given, which equals to what, 70 gram per mole. Small m is the required mass, and then crisscross 0.1 multiplied by what, 70, gives what, 7 gram. Okay, the required mass of the metal is 7 gram. The mass, by applying the law of conservation of mass, the mass of metal M plus the mass of oxygen equals to the mass of the metal oxide. Okay, the given mass of the metal plus the given mass of oxygen gives the given mass of the metal oxide based on what the law of conservation of mass. Okay, 7 gram metal plus the mass of O2 produces what, 9.4 gram, and then the mass of O2 is 2.4 gram of what, O2. Then calculate the number of moles of O2 because we are asked to find the number of moles of what, oxygen. Okay, you have to convert this given mole into what, I mean this given mass, this calculated mass or required mass into what, number of mole. Okay, number of moles of oxygen equals to the given mass or required mass of O2 divided by the molar mass of O2. Okay, 2.4 gram divided by 32 gram per mole, which equals to 0.075 mole. Therefore, the answer is D. Okay. This is another question. The reaction of 7.8 gram of benzene C6H6 with excess HNO3 resulted in 0.90 gram of H2O. What is the percentage yield? Okay, you have the molar mass of the reactants and products here, and the chemical reaction is given. Then you can calculate the percentage yield. Percentage yield equals to you have given mass, actual yield of H2O 0.9 gram. The percentage yield is required. Percentage yield equals to actual yield divided by theoretical yield multiplied by what, 100%, but theoretical yield is not given. So you have to calculate the theoretical yield first. Okay, from 7.8 gram C6H6, you obtain what? X amount of water. If you obtain 18 gram of H2O from 78 gram of what, benzene. Okay, then use the mass ratio 7.8 gram divided by 78 equals to X over what, 18. Okay, 7.8 cancelled by 78 equals by 78 1 by 78 0.1, which equals to X over what, 18. 18 and then crisscross 18 multiplied by what, 0.1. This gives 1.8 gram of what, H2O. This is the theoretical yield. Then calculate the percentage yield. Percentage yield equals to actual yield divided by theoretical yield multiplied by what, 100%. This gives 0.9 divided by 1.8 times 100%, and gives 50%. The answer is what, C. Okay, in the reaction, calcium plus water gives calcium hydroxide plus hydrogen gas. What volume of hydrogen at standard temperature and pressure will be liberated when 8 gram of calcium reacts with excess water? The atomic mass of calcium is 40. The atomic mass of hydrogen is 1. The atomic mass of oxygen is 16. Then calculate the volume of what, hydrogen. How can we find? Okay, solution. You have 8 gram of calcium given, used to produce X liter of what, hydrogen. Okay, air mass ratio, we use here volume ratio. Okay, 8 gram divided by 40 gram, which equals to X over 22.4 liter. Gram cancelled by gram, and X equals to 8 times 22.4 liter divided by 40, which equals 179.2 divided by 40 liter. This gives 4.48 liter. You are asked to find the volume in centimeter cube. Therefore, what is the conversion factor, the conversion units that used to convert liter into centimeter cube? 1 liter equals 1000 centimeter cube. Therefore, by using this conversion factor, the volume in centimeter cube is 4,480 centimeter cube. Okay, therefore, the answer is A. The answer is A. Okay, thank you for watching. This is enough for today. Please like, comment, subscribe my channel. Thank you for watching. Bye bye.